Student, we're looking at piecewise functions in this video, and a quick way of learning this is to look at a particular problem, and we're talking about sort of like a ride or a roller coaster type thing at an amusement park. It's modelled by a function. Now this might look unusual. In fact, if you have a close look at it, you might even go, which function do you mean? This one is represented by three functions. Perhaps you're thinking, how can this be? You can't have multiple personalities. Well, in a sense it does, but it depends on what element of the domain we're at here. We've got three domains listed, and if you have a close look there, basically you can see that they don't overlap. Where the first one ends, the second one begins, and the third one takes over from the second one. And the basic function changes as we go through each element. That's called a piecewise function. It's in different pieces. In this question we're required to do three main things. So let's firstly use our graphics calculator to enter the piecewise function. So what we do is we hit the templates key, and we will need this one here because it allows us to put 6 bits of information in. So double click, piecewise function, yes I want 3 pieces, and it gives us a template. Now I need to enter the parts in. So just cascading the pages there, we enter in the first one, so it's negative 0.2 open brackets x minus 5 close brackets, and that's all squared, and plus 8, and that's valid from 0 less than or equal to, which you can go into catalog for, and x, and then less than or equal to 7, and again catalog, try again, just to save time I've entered all the rest of that in. Remember at the beginning too, I might have overlooked the fact that you've got to hit define f of x equals, then hit the template and all that in. It'll give you a confirmation message once that's successfully been done. Another way you can do that is to just copy all of this and paste it into the entry line, which is this bar here, and I've pasted it and then hit enter, and then you'll see it plotted below. And you can move all of the text out of the way if you need to. I'm going to adjust my window, and we only need to go up to 16, so X max, I could trim that down. I'll just take it a bit further past and probably just trim a little bit of it off. See if that helps a bit. Okay, so we can move our text out of the way. Okay, so that's basically what we've got here, and it's nice and smooth. So what I'm going to do is take a little screenshot of that and put it in OneNote, which is what I'm working in, and just for reference sake, and bingo, and place that in. We've got paste that there, and I just have to scroll over and we've got it there if we want it, and we might want it. So let's go back to the question. What have we got to do now that we've got this thing modelled? Find the height at the start of the ride. Okay, now if we read this, it says h of x is the height of the rail above the ground, and x is the distance in meters from the start of the ride. So at the start of the ride, x will equal 0. So at the start, we're looking at the first part of the piecewise function because we've got x equals 0, and so we're only using the first part, so that's h of 0 equals negative 0.2, 0 minus 5 all squared plus 8, and we evaluate that, and that'll give us our answer. we get 3 meters. So it's the height of the rail is 3 meters at the start. Next part, find the height of each of the following distances from the start of the ride. Just to save time, I'm just doing the third one only. So if you can do that, you should be able to do them all. So when x equals 15, you can see we use the third part of the piecewise function because it fits in that domain, and I've found h of 15. You can see we've subbed in the values and we've just got to write in our answer, which comes to 4 meters. So part A and B sort of similar. Now for part C, the last bit, find the horizontal distance or distances from the start of the ride when the height is 6 meters. So we're in fact given h of x, we're given that value and it's 6. Now we've got to choose the correct part of the piecewise function, and let's have a look. By looking at it, we don't know which one it is, so we're going to have to try it on all 3 sections. So all 3 piecewise functions, we're going to see if there's meaningful solutions for them. In the first section, we've written here 6 equals the corresponding parts in the given piecewise section. Okay, so we do 2 things there. We subtract 8 from both sides and we divide by negative 0.2 on both sides. We get 10 equals x minus 5 all squared. On the next line then, we have to take the square root of 10 and then add 5. So now if you take the square root, you get 2 numbers. Okay, you get a positive and a negative. So you can see there's 2 answers there. They'll both give you answers if you approximate them. So root 10 plus 5 is about 8.16. Negative root 10 plus 5 is about 1.84 if you round it. That answer is invalid because if you look at the domain for the first section, it only goes up to 7. You see at the top there. So that's outside of domain. That one's not valid. So that's the one we're after for the first part. So once the roller coaster has moved along about 1.84 meters, it is then 6 meters high at the rail, but that might not be the only solution. So we write the relationship for the second one, and then we've got to solve it by subtracting 12.8 and then dividing through by negative 0.8. So let's do that. Then we do that and we get 8.5 meters. So again, it's hit 6 meters after 8.5 meters. And let's try the third section now. I'm just going to put that in to the right. So the third section, we go through the same process with the last part of the piecewise function. We get 6 equals negative 0.2, etc., etc. So what we need to do then is rearrange and solve. Okay, we're applying our usual algebraic steps. We get up to x minus 13 is approximately equal to 3.74, so we add 13 on and we get x is approximately equal to 16.74 meters. Now let's check if that's in the domain. It is not, because the domain only goes up to 16, so that one is rejected. Okay, so we haven't got that many solutions to this because some of them are outside of domain, so that one is rejected. So which ones are our answers? 1.84 was okay, and